Good day. Today we're looking at conditional probability. Given events A and B, find the probability of event B occurring knowing that A has already occurred is conditional probability. The notation is P parenthesis B vertical line A close parenthesis. The way you read that, the probability of B given A. Now how do I find this? Well, I'm going to find the probability of where B intersects with A divided by the probability of A occurring. So for number 1, find the probability that P is prime given it is greater than 8. So I'm going to find the probability of that was not a P, a prime number greater than 8 divided by the probability of a number greater than 8. Now I've listed 1 through 20 to the left. The prime numbers greater than 8. 11, 13, 17, 19. There are 4 numbers greater than 8. Divided by how many numbers total are greater than 8. That is 9 through 20, which is 12 numbers. 4 divided by 12, this is 1/3, about 33%. Okay, number 1 is finished. Number 2, find the probability of a number at most 15 given it is a perfect square. So the probability of a number at most 15 given it is a perfect square. So squares up to 15 divided by the probability of selecting a perfect square. All right, perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. That's over 20, so I'm done. So how many squares do I have up to 15? That'd be 1, 4, and 9. So 3 divided by how many perfect squares do I have? 4. This is approximately, well, this is exactly, rather, 75%. And we are finished. Take a moment, try 2 and 4. 5 and 6, we're talking about marbles. A bag contains 8 red, 2 blue, 4 yellow, 6 white marbles. If a marble is chosen at random, find each probability. Find the probability of choosing a yellow marble, given it is not white. Well, how many yellow marbles are not white? That is all 4 of them. How many marbles total are not white? This is going to be 8 plus 2 plus 4. So the red, blue, and yellow marbles. Actually, I don't like the way that's written. Let me drag that down a little bit. 14 marbles are not white. This is 2 over 7, which is about 29%. Try number 5. The spinner to the left is spun. Find the probability. I have a constant given it is unshaded. So my unshaded values are B, C, consonant, not constant, sorry. B, C, F, I, K, N, and P. My consonants here that are not shaded are B, C, F, K, and P. That's 6 of them. The unshaded numbers is the 6 I just named, and I. So 7. And that's about 86%. Try 7. You can also try number 9. I think you're capable of doing it. If not, come back. I'm going to work number 10. Well, and 11. A date in the month of September is chosen at random. Find the probability that it is an even number date given it is before September 20th. All right, there are 30 days in September. So, find the probability that it is an even number date given that it is before September 20th. So I have 2, 4, 6, 8, 10, 12, 14, 16, and 18 as my days before the 20th. That is 9 days. The number of dates before the 20th are 19. 47%, and I'm finished. The probability of Jasmine studying for a test and getting an A is 13 divided by 16. This is number 11. If the probability that Jasmine studies for a test is 9 over 10, find the probability that she will get an A given that she did study. All right. The probability of studying and getting A, the intersection, is 13 over 16. That goes on my numerator. And she's given that we study, that's 9 over 10. Now, to be completely honest, I don't know what that one is in my head, so let's go to Desmos. 13 over 16. Divided by 9 over 10. $90.3. Okay. Try number 12. For questions 13 through 15, we're using this Venn diagram about coffee and tea. What is the probability that I do not drink tea given I drink coffee? So for my coffee and tea, these people drink purely coffee, these people drink both. So if I know I'm drinking coffee, I know 24 are not drinking tea. How many people drink coffee? This is 24 plus 12, 36. This is 2/3, so about 67%. Try 13 and 15. For 16 through 18, of the 400 freshmen at Westview High School, 92 students are in band, 60 are in chorus, 20 are in both band and chorus. Before I get to any of these problems, I'm going to draw this diagram. So I have Westview High School. Students are in band. Students are in chorus. And I have a total amount of people at 400. $60 are in chorus, 20 are in both. I'm going to start with my 20. If 60 are in chorus, I'm going to take out the 20 in both. 60 minus 20 is 40 students purely in chorus. Likewise for band, I have 92 minus the 20. 72 students are just in band. Now these students is 92 plus 40, 132. So 400 minus 132 is equal to 268 students are in neither. Okay, now I should be able to answer any of the problems on this page. Let's go to number 18. What is the probability that I have a student in band given they are not in chorus? Well, first, how many students are not in chorus? This is 400 minus the 60 total chorus students. So 340 people are not in chorus. Given I'm not in chorus, how many are just in band? That is this left circle, 72 people. This is, I'm not sure, so let's type it in. 72, 340, 18 over 85. 21%. Okay, try numbers 16 and 17. Let's look at a two-way table now. So we've been doing conditional probability. This is the same thing, really, as what we've done so far in this unit. But we're looking at a table instead of just given word problems. All right. I'm going to go to number 2 because after I do number 2, I can trust enough that you can fill out number 1. All right. For this table, I have checked bags as my rows and the final destination as my columns. So for checked bags, a total of 136 people said they did check bags and 50 said it was their final destination. So to fill in this blank, I'm going to do 136 minus 50. To fill in the bottom left blank, which is the yes, it is our final destination total, it is 50 plus 16. To fill in the checked bags, not at all, so the right row, second row, I'm going to do 16 plus 48. For the total column, I have options. I'm going to show you where they are here in a second, so I'm going to leave that one blank just for a minute. Okay, 136 minus 50, that's 86 people said no. Or I could have done 134 minus 48, your choice. That'd be the no column anyway. For the yes column, 50 plus 16 is 66 people. For the no row, 16 plus 48 is 64, not 54. Okay, to get the total, I can either do 136 plus 64 or 66 plus 134. Either way, this is 200. Okay, that should be pretty easy. Now, based on number 2, I want to give the joint and marginal relative frequencies using the data from the example. Now, that's a lot of big words. It sounds really hard. It is not hard at all. Here's what I'm going to do. I'm going to go and I'm going to open Desmos. So, here is Desmos. The main thing to remember, the total column is my denominator. So in this case, 200. Now I'm going to fill in the numbers in the numerator. 50 is 25%. Or you can put 0.25. My personal preference, I like 25%, but your choice. 86 gives me 43%. I'm going to put in the no row, yes column. 16 is 8%. And then the no row, no column, 48, 24%. You do have the option to go through and type in 136, 64, 200, 66, 134 to get the rest. I'm just going to add 25 plus 43 is 68. 8 plus 24 is 32. Your total should always be 100%. 43 plus 24 is 67. 25 plus 8 is 33. And finished. Try number 1. Go ahead and try number 4 if you're comfortable with it. If not, let me do number 5 and come back. Number 5. A test was given to 3 classes. Sorry. The results of the test were shown below. If a student from one of these classes is chosen at random, find each probability. All right, before I look at the problem, I'm going to finish filling out this chart. So, 19 plus 24 plus 21. So this is 45 plus 19, 64, and 16. So 80 people total. $19 plus 3 is 22. 24 plus 8 is 32. 21 plus 5 is 26. All right, there's my chart. What is the probability that I choose a student at random and he is in Class B? The total people in Class B is 32 over my 80 people. Now, I want you to notice this is the same thing as what I was doing to find the marginal relative frequencies in the above table. So if you would have done that, make it a little bit faster. But anyway, this is just identifying it. 32 over 80, that's 2/5. So it's going to actually be exactly 40%. What is the probability I'm in Class C or I passed? All right, the probability of being in Class C is 26 students out of my total amount. The people who passed that were not in Class C is 64 minus, well, I'll go this way first. Plus 64 passed over 80. And the people who in Class C who did pass were 21 over 80. Okay, this is mutually inclusive. Make sure you subtract out the people in both. Okay, this is 64 plus 5, 69 over 80. You can type that in Desmos if you don't want to do it in your head. I don't want to do that one in my head, so 69%? No, 86%. 0.25. 86.25%. Okay. What is the probability that I did not pass given I was in Class A? So, how many people did not pass that were in Class A? That would be 3. And how many total people in Class A? 22. That's about 14%. And I'm rounding there, but close enough. What is the probability that I passed given I was in Class B? The people in Class B who did pass are 24. The total people that passed were 64. It's 3 over 8, which is 37.5%. Number 5 is done. Try number 4 if you didn't already. All right, last one. A restaurant has chocolate, strawberry, and vanilla ice cream. The table to the left gives the choices of the last 200 people. Before I move on, let's fill out this chart. (42 plus 55 is 97. 28 plus 22 is 50. 18 plus 35 is 53. For the cup row, I don't really need that line there. That was bothering me. For the cup row column, I have 42 plus 18, 60, plus 28, 88. Now the problem is I have 200 people. So instead of me doing 55 plus 22 plus 35, honestly, not that difficult, but still, 200 minus 88, 112. There's my people. Now, we'll go to Desmos to fill out my marginal frequency chart. Okay, my denominator needs to be 200. (42) is 21%. (28), 14, and 18 is 9. Now you can add these together, or you could just put 88. Either way, 44%. Okay, now for the cones. I got 55, which is 27.5%. 22. 11. 17.5. And now we can add these for the rest. 56%, 26.5%, 25%, 48.5%, and 100% total. Very good, we're done. Number 1, what is the probability that I choose a cone? Look down the cone column, 56% finished. What is the probability I choose a cup or chocolate? Well, I got a 44% chance of choosing a cup, plus a 48.5% chance of choosing chocolate. These do have an intersection. There are 21% who like chocolate cups, so minus 21%. So this is 23 plus 48.5, 71.5%. So, in case you didn't keep up, this is the probability of a cup, probability of, well, I just now realized C is not going to work for chocolate because it's also in cup. So, CU for cup, CH for chocolate. This is the probability of a chocolate cup. Okay, there we go. What is the probability it is strawberry given it is in a cone? Well, what is the probability of a strawberry cone? That is 11% divided by the probability of a cone, 56%. I do want to show you this real quick. 11 over 56. This will give me my answer of 19.6%. If you was using this as a decimal, you're not comfortable putting in it the percentage numbers without the decimal, that's fine. 0.11 divided by 0.56 as a decimal answer, it is the exact same thing. I just wanted to show you to make sure you're not going to mess up later. So about 19.6. What is the probability it is a cup given it is not vanilla? Okay, vanilla is 26.5. 100 minus 26.5 is equal to 73.5. There's my denominator. The probability of a cup given it is not vanilla is going to be the strawberry and chocolate added together, so 21 plus 14. $35 on top. And this is 35 over 73.5. Is that right? Yep. 47.6%. Okay. Make sure you've tried number 4. Here's your answer key. This is all that we have today. I hope you have a great rest of your day.